Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And you heard that we got Ed back with us. He's back having fun with us. He's been taking care of some family stuff. So, we finally got him, back around again. And, we're going to kind of continue down the robot path we've kind of been on. We talked about automate. We're taking care of that process, and then we kind of talked about robot and cobot innovation. And the thing is that kind of follows through into that, I guess you could say, is robot and cobot safety and cybersecurity. Because the thing is we can implement these robots, we can implement these cobots, we can implement all this stuff, but if they're not safe and they're not secure, then what are they? They're a paperweight. Because then the robots don't do their job. And the cobots don't do their job. We touched a little bit on the innovation side on what cobots are and the fact that you can tap them and they'll stop moving because they have the gyro sensors on board. But we kind of want to dig a little bit deeper into some of that. But the thing is if things aren't safe, people can get hurt. Mm-hmm. People can die. People can, hate to be gruesome, but if they can. But the thing is what we see the most of is the fact that people are going to these systems because they want to reduce workplace injuries and workplace stress and stuff like that.
Yeah.
So, as we kind of go forward, we're going to start kind of digging into that type of stuff is, the safety side of it, and also the cybersecurity side of it, looking both at robot and cobots. Because some people may not buy a cobot, they may buy a regular industrialized robot, and we've talked about, the fact that you can purchase them on eBay for $9,000.
Yeah, they're getting cheaper.
They're lowering their price while cobots are going up in price. So, in some of those, you kind of see some of the prices like the Fanuc cobots, the CRX line, used still being about $30,000, but still worth it, for their bigger, range of CRX robots. But that's here nor there.
Right.
So what I'm thinking when we're talking about safety and cybersecurity and all of that, when it comes down to robots and cobots, what are y'all thinking?
So the first thing, like you talked about it earlier, I mean, I would say safety has got to be paramount. I mean, cybersecurity isn't in a sense, like safety on a digital side. So it has to be foremost in your mind anytime you're working with something. Like, of course, cobots don't have to be the largest thing, but fundamentally in a lot of cases they're going to be a large robot arm because it's doing something a human couldn't, and it isn't designed to make the worker obsolete. It's there to make sure that the worker isn't a liability, right? So it's I'd rather have a robot arm break than the worker's arm break, right? So if something has to get torqued up to like 100 newtons, like you're gonna need someone who's physically fit to be able to do that, and most of the workforce isn't gonna be able to do that without popping a shoulder out of the socket, right? If they're not careful. So it's about not only the safety and security of the worker, but also the so that the company can make sure that they're minding their P's and Q's, and a safe workplace is an easy way to ensure you have a workforce. Mm-hmm. If I heard that the robot on station 12 keeps hitting the person that works there, I wouldn't go to station 12, right?
Yeah, maybe it's playing patty cake.
Yeah. So, but then there's also you think of the software side of the house, like if someone's able to hack into my robots or to get to my system or put improper data in somehow, then not only will it compromise my system, it could also endanger the safety of that employee. So it kind of it goes full circle. So yeah, I mean, when I think cobots, I'm thinking that collaborative robot that's assisting you to finish or be better at whatever your position is. So I think that they would be useful, but yeah, it's if you don't consider safety, then I think that you're planning for an incident.
Yeah,
so
makes sense.
So I would say I'll offer an analogy with the umpire, the hind catcher, and the batter. The batter being the human, the hind catcher being the cobot, and the umpire being the protocol in place to ensure that the two work together. All right, so basically when you're talking safety, we're talking about the robot has to operate in his zone, so we have safe zones set up. The other thing we take into place is we monitor the velocity of the robot. So the robot is moving at a certain velocity and it cannot exceed that velocity. So it can only go so many meters per second and so forth. The other thing you would do is that when the human is in the safe zone, the robot always has to defer to the human, regardless if the human is out of sequence or not. The human always has preference. So you have to go beyond just sensors inside the robot. You may even look at incorporating vision systems to verify that the zones are being abided by, and the human always has the right of way. So those are some of the things you can do. The other thing is if a robot fails, the robot always fails safe. So you do things like brake tests after so many hours to ensure that the brakes are working the way they're supposed to, because it's a mechanical thing, and over time it can. The other thing, you want to have protocols in place that you do preventive maintenance, TPMs, and you verify so many hours that the robot does what it's supposed to do. You want to do TCP checks to verify that the robot is in the right orientation when it's doing the work. So those are some of the things you would consider when you're thinking safety. It could go a little bit further than that. You could say, also, I care about the safety of the machinery. So other than just the operator, there's also an aspect that I do not want to damage equipment. I don't want to damage product. And some people don't put a high preference on that, but that's something you should consider.
Because you were talking velocity and position, but I was like, would it think about acceleration of like would acceleration end up being something it has to
the laws that you put in the software dictate
everything. Okay.
Yeah.
Okay.
The velocity you tell it to go is where it goes.
Okay.
And then you also have to consider automatic, semi-automatic, and manual. So you have to consider that those things have to be abided by. And then I'll touch on the cybersecurity part. The cybersecurity part, hardening is what you want to do. That makes sure that if the version of the firmware doesn't match, robot falls into a faulted condition, and until it matches, the robot is not allowed to do work. The next thing you want to do is you want to do zone integration, where the robot is in a network that does not connect to a business. So the business network does not connect to the shop floor network. And then the third thing you want to do is you want to make sure that you do scanning to make sure that any vulnerabilities that you've seen can be addressed, so you can do updates. So you want to make sure you keep the robot updated, or the hardware, the hardening that you do, keep it so that thing can never be done.
Okay.
This is where, and I think when you brought up the velocity testing and velocity mitigation, I kind of found that interesting, because the fact is we have, or there is, cobots out there that are cell safe, and they're human safe, human rated robots and stuff like that, which, if I'm not mistaken, is their default velocity. They have a default velocity pegged into them, so they don't go as fast as you think they would. And they're only there to do certain jobs anyways.
Yeah, and I think some of that's going to be based on the firmware.
Yeah.
So basically, in some of these things, I take that back. Let's back up just a little bit. That's not totally correct. Some of it's going to be based on the mechanics of the robot, and what it's doing. The gearing is going to have some effect. Gravity is going to have some effect. The braking is going to have some effect. As far as if I'm at a certain velocity, I hit the brakes, I should stop at this distance, so a safe stop distance. But in general, the robot has an overall speed. I can lock that down, and I can say it cannot go beyond this, but you have to password protect those settings or parameters so that a human, or say somebody that penetrates your network, because most people have a misconception that things that are done in a cybersecurity or a cybersecurity attack is today. No, it's tomorrow. Most attacks they're setting up for tomorrow, so they're not doing the gamuts move. They're doing other things. They're setting up this so that they can have persistence in your network, so that they can find some value that they can exploit, or they're using the resources from your system to gain money. But in general, just to stay on topic, the things you have to consider with the robots, design is ultimately, when you get a cobot, and whatever the application is, the design has to account for the human. The human has to account for the robot or the cobot. So the two have to understand how they work. And that comes from your SOP, so your standard operation procedures. That also comes from your risk mitigation, so that you know where the robot can fail. So you know, based on base frames, based on the user frame, based on if the robot is mobile, if it's a gantry robot, where is the robot in space? Those things have to be planned out in the beginning. So you don't just go grab a cobot and stick it somewhere and say, hey, well, it's safe. Yes, the manufacturer is safe, but is it the right application?
Right. And the thing is, and I think that's why one of the very reasons why I love, cobots. I would say I probably like cobots more than I like industrial robot, just because of they're specialized in certain things. It's what they do. They're not a jack of all trades, master of absolutely freaking nothing. They are what we ask them to be and what we want them to do. Think about it, Flippy. You have a cobot that's sitting there making burgers. All right, its entire job in life is to flip burgers. That thing has never been designed to be a welding robot. And I think that especially like what I saw at Automate, the increase of the use of cobots and stuff like that, and the integration of scan technology in some of these robots, for safety scanners and safety lenses and stuff like that, built into the robot itself is it's one of those things. It's heads and shoulders where it was 15, 20 years ago. But the thing is we also see a rise on the industrial robot side of the house of people going to ROS, the robot operating system, which is a system kernel that rides on the controller, that is community based.
Yeah, real-time operating
robot operating system. And there's very few. There's a lot of different types of controllers these things work for, but it's all like done by the community. And the good thing about ROS, and I've had the opportunity to meet a lot of the guys, one of the guys from ROS, actually the leader of the process, is the fact that they put a lot of time and energy looking at the controller that they're working with to the robot OS that they're working on, its security and how they make sure that nothing gets into the system that's not supposed to be there. But it also has a lot of manufacturing backing. You see a lot of KUKA getting involved, a lot of ABB getting involved a little bit, and a little bit more of the guys from like Yaskawa and Moto Man. You don't really see a whole lot of Fanuc getting involved, but they're getting there because it's all been locally built.
So like the ROS, and it's probably their acronym, but if you go back, the RTOS,
right,
which is where the microcontroller,
real-time operating system,
was. I think the military had a lot involved in that.
They did.
That they developed that, and then I think the CAN bus system started to get involved with.
Yeah, CAN bus originated from RTOS,
and I think that's actually rolled over into that Cobot. I think that's what's allowing the miniaturization and the processing power that you get from a microcontroller, as opposed to having a full microprocessor.
Right.
Has actually enabled the cobots to be smaller, and the intelligence that you're able to put in. Like, just go back to where people still are using the Raspberry Pis and the different type of systems. They're even using those for desktop type robots for like STEM. So I think this is something that's just like evolved from.
It's become the adult version.
Yeah, the Pi 5's got a lot of computing power, so it's got definitely got enough.
And the thing about ROS runs actually on the robot controller itself, not on a secondary controller. Yeah. So which I know it can run on both. It can run on a standalone and be attached to the controller, and vice versa. it becomes the adult version of the playground, because now we're trying to figure out how to modernize robots, make robots kind of do what we want to do, make them easier to program, make them easier to be used in the workforce. Which, for the companies who don't have robots, having a ROS enabled robot is actually kind of nice. But now with cobots going to the block programming, it's what I joked around about with a couple of the software engineers at Automate was the kindergarten programming. It's block, 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 if block, 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 block. And do you remember I see the chuckle get, but I see the chuckle get ready to happen. Do you remember the kids programming language that they came out with to make apps for? I think it was MIT, that you put them all together to create the app. Remember that?
Yeah, I mean it's
same thing.
But so this is what I would say. It's libraries.
Right. Exactly.
All modules or libraries,
Yeah.
or a class. It can be a class, it can be a module, it can be a function, whatever you want to call it. But basically, they built the libraries.
Right.
So who makes, like in Python, for example? Just as an example, we getting off just a little bit. When we talking about crunching numbers, nobody's writing their own algorithm in Python. They're using the libraries that's already there.
Yeah.
So it's a great idea. Why have people generate?
I had to sneeze for a second. It's gone.
But why recreate libraries?
Yeah.
Unless you're trying to do something one-off.
Yeah.
When when a community's not only supporting that, but they're finding any bugs or whatever.
It just makes sense.
And,
I mean, especially in any type of application development.
Yeah.
We talked about it with Prusa Slicer, the 3D printing software is like Super Slicer. That's just an extra layer to what Slicer already was.
Yeah.
So it's just building upon that idea as opposed to building against the idea.
And I got to play with it a little bit with ABB, and I love it. To be honest with you, it's just a little screen, and it's drag and drop programming.
Yeah.
And once you program it up, you hit the OK button, and off she runs. It does what it wants to do, and then off it goes. It's kind of like the guys. And the thing is, this is where we kind of get into cybersecurity. Is that type of stuff. You're completely offline. God forbid. But but this is where it's going to get funny. We talk about collaborative. We really can start getting into like what Nero brings to the table of the cognitive side of the house, where these robots are actively learning your processes.
Yep, machine learning, deep learning,
and it's
AI.
built into the robot. So the robot does the learning for you, which is pretty nice, to be honest with you. And it brings a lot to the table. And the thing is, but they have something called the Neroverse, and it is literally, they give the ability for these companies to build stuff to tie to their sensors, scanners, measuring systems, and that type of stuff.
Once again, with PLCs,
Right.
they're libraries.
Yeah.
So there are libraries for just about everything that you can think of, and then there are devices. So when you go to a PLC and you want to add an analog device, there is that device. You type in analog input or analog output, and it gives you a list of devices that work with that. And then if it's not a standard device, there's an optional or miscellaneous group that you can add these other devices. You have to get their, I guess, their interface between the two. But yes, I mean it's basically what they've done is taken an industrial process with a robot that was doing like, hey, take these instructions, follow these instructions, and now what they're saying is okay, I want to have the robot do the ergonomic stuff that we're having repetitive issues with rotator cuffs or knees and so forth, and let the robot do that repeated motion because there's no problem for it.
Right.
But the human is there to also work with the robot because he can't do the stuff that takes human fingers. The robots have advanced, but they have not gotten to the point that they
don't
can
have thumbs
do
yet.
some of the things. What an interesting,
Like
the
triceps,
claw.
like a claw. Yeah.
And the thing with the fingers is touch, manipulation when you're touching, And then it's some of the other things is it's the way you move around those axes.
Right.
The robot can move around those axes, but I don't think the robot has the same touch and the same dexterity. What do you call it?
Dexterity.
Dexterity. I'm sorry. Thank you, sir. Dexterity as a human.
No, it's true, and it's good that we actually started talking on the cybersecurity software side of I mean, cobots and things like that. We're all talking about the use of it, and it's useful, right? So the one thing that like I think most people need to consider is around the cybersecurity, where you're saying I don't want anyone to access my system. What a lot of people don't realize in the robotics is that they're sitting on a wealth of data. Of if you have gluing systems, if you have weld systems, you can take measurements on that, and we've talked about it like before with the company Audis and things like that. And Ignition, they are checking stud welds and things like that to validate quality and stuff like that. So it's very important that you maintain that data, and then on the piece that you're talking about where they're programming it in blocks and block by block by block. I think it makes sense because it gives a quicker on-ramp for programmers to learn, but I think that we need to take it a step further, and I think I had someone explain to me PowerShell before, like very simply. There was 3 levels of user. There's PowerShell just for information, so that person just pulls it up and says IP, checks what's my computer information. There's someone who writes programs for the end user to use. So the person who coded ipconfig is writing that, and then there's the people that develop the tools for those people to use.
Right.
So that person who's using ipconfig is using a tool like a disk manager to validate and check all of your pieces. So I think that's the same level of I would consider that you should have when thinking about the cybersecurity is you think about the end user, the person on the line, how are they going to deal with it, and how can they protect your data, and not only that, how could they become a breach, a vulnerability to your data? Is there any way that they can insert a USB stick or something and take something they shouldn't have? Is there a way that they can send something outside to the internet, so where another malicious company or entity is trying to get to you? So closed networks is probably the best bet, and then you think the person who's developing the closed network also has to make sure that their coding is made in such a way that they're not only not endangering the life of the worker, but thinking about the life of the robots too.
Yeah.
So this is good.
Yeah.
So I'll touch on what you're talking. Let's do the cybersecurity part.
Okay.
So I'll do it from I'm gonna do it from 3 levels. I'm gonna do it from the hardware, software, and user interface. So we'll start with the hardware. So I would assume that it makes sense for most of the developers to use trusted platform modules because there is no changing. It's hardwired. You cannot change it.
No.
It's almost like having BitLocker. It's burned in unless you change the chip. And if you do change the chip, there is a sequence that has to happen with that chip. And if it doesn't happen, it shuts down the system. So TPM would be the best way to go far as no firmware changes from the manufacturer. The OEM has set the firmware. They don't want to change unless they initiate a rollout. The next step would be the software. The software should have user access levels. So you should have users, you should have super users, and admins.
Yep, there you go.
You should have those layers, and they should be password protected, and everybody must do that. And not just password protected, the password has to meet a certain criteria, and you must use multi-factor authentication also. So
use the watch key and stuff like that.
It's two or multiple things.
Yeah.
Whatever you want to use. You can use whatever systems you want. The last layer of that is your fault tolerances, your input validation, all of those things should be done in the programming. And I know they don't want to do it because they don't want to have somebody call them and say, hey, I can't do this, blah, blah, blah. However, you cannot go in your car, generally, and say, hey, you know what? I want to change how this sensor works with that safety bag. Pretty sure you can do it, but I'm pretty sure when you manipulate that safety, that interaction, and you have an accident and you have a malfunction in the airbag deployment, they're going to go back and check and say, you made a change here.
Yep.
So those are the things I think you should have in place.
And I agree with all of that. And the one thing is, and what I love, especially now how we're going to a more, I guess you'd say, 21st century approach when it comes down to robot programming, is your industrialized robots still need professional programmers that go through, like either through a robot program or, a community college or a 4-year institution or something like that, whatever they want to do, right? But your cobots have now got to the point of where they arrive at your facility, and you unbox them, you set them on a table, you plug them in, and you go to the GUI that's built into the machine, and you follow the prompts, and you set up all your certificates and all the other stuff you had to set up on the machine, and it walks you through how to do your first program. And so they make it, programmer agnostic. You don't need a programmer if you don't want one, or if you don't feel comfortable with doing, what is required as far as with, the pointing to different blocks and setting it up and stuff like that. And I think that, we've kind of got to that point of where now businesses are forced to take more responsibility for the security of the security of their robots. Instead of saying, well, it's the contractor, it's the programmer, it's maintenance that owns this process. No. It's the engineer, that owns the process, that owns what's happened, that's owned the security of that robot, because they're the ones who put it in. And so now I think we've gone from the, I guess you could say what I like to call contractor-owned robots, where they're the ones who can only do everything unless you have people that are specifically trained for that robot and for that station, to a more locally owned robot where people kind of feel, I guess you'd say, empowered. Right. Because they own the robot. They care more about the cybersecurity of that robot. They care more about the safety and security of that robot. And they do more research into those robots. I think you get these companies out there buying like the Kuka KRC6s and KRC4s and stuff like that. And they don't really put a lot of effort into them. It's like, we got programs to do this. However, a mom and pop shop buying these cobots, they're the ones installing it. They're the ones maintaining it. They're the ones making sure it's secure on their floor because they don't want to lose that investment. But they want to make sure it's safe so they're not the ones getting sued, if something happens. They're testing to make sure that these robots, their crash sensors are in place. Because by reaching up and tapping a cobot while it's moving is going to make it come to a stop. If it's, the thing is if the sensor's working that way.
Yeah, there you go.
But the thing is
it programmed to fail in a safe
manner? The thing is, the good part about some of those cobots and how they're set up, that's a default program that you can't change, which is a good thing.
Yeah.
And that's where I kind of, will give the praise to the robot companies who are building these things, is they're finally putting safety first in these things instead of putting profit first.
Yeah.
They're finally putting in, hey, guess what, dummy? You cannot do this. If it hits you, it is going to stop. Yeah. And it's, but we're going to make it where you need to learn how to program this thing. If you want to, then you own it. You make sure this stuff works. Yeah. Even though we'll make sure the safety side of the house works. Yeah. And we'll provide you some, support if needed.
Yeah, and to be honest with you, man, I don't want to say that we have all the solutions, but it's not difficult. You just think about a process and so a lot of cobots and a lot of robots in general use hydraulics, right?
Right.
And a lot of those things you need to have hoses and things like that where
used to. Now it's all built in the arm.
Now it's all built in.
Yeah. If you look at the for example, what I was showing him earlier is
servos.
Yeah. If you look at for example, if you look at the Fanuc CRX series, right? They are just tubes.
Okay.
Literal tubes. Okay. For the CRX, what is it, 7, the I-7 through I-10? Before it bumps up into the I-20s and stuff like that, going into the green cobots.
Well, so the point I was going to make,
I know what you mean,
regardless of the mechanism that it's using, like just think hydraulics.
Yeah.
So in PCs with like water cooling and things like that, you know, water and electronics don't work well together. I feel like we should know. Yeah. So if your water cooling system has a leak, you just lost all your money.
Yeah.
However, if your water cooling system has it if the developer or the manufacturer understood how high and low pressure systems work, if you create a leak, if you can fundamentally have the fan point in a certain direction, create a certain suction to where it's not, the pressure is now high at those exits and air is being sucked in as opposed to the liquid being pushed out. So it brings everything back to a reservoir and saves your computer. So that you know, probably is just a smart way to think about, you know, a simple system that you're already using.
Right.
But I'm saying take that thinking into any Cobot systems, and
makes sense.
so if it, like you're saying, fail in a safe way, and that's like that's
Exactly.
just the first example that popped into my head is
But that's a valid because that's what they do with gas.
Yeah.
Where it's in the earthquake zones, they install a sensor. If it feels the vibration, it's a cutoff. It cuts off the supply.
And
so the same thing with a leak. You just cut the supply off.
Yeah.
Industrial robots are a great application to have if you want to take a bath in some sort of chemical or goo that you are not planning on taking a bath in that day. Because when they go, they go, and it can get kind of comical. You know, next thing you're covered in hydraulic fluid, going, "Well, this is weird."
Well,
you know,
so
or weld water.
How did I get
weld
here?
water's a fun one.
So generally with most robots, we're just talking just the robot, not anything external. We adding most robots going to have pneumatics, so some type of air for whatever pneumatics you're using for grippers, cylinders, and you're going to have some oil where you're running gears in certain axes, and then you're going to have grease for where we have joints. Just in general. From the experience I've had from working with robots over 15 years, generally they do not fail unless there's a defective seal or someone took off a access panel and did not correctly put the access panel back. But in general, I have not seen one fail where we have a massive leakage. And the way that they design these things, that chamber is isolated from the electronics. So just in general, but one of the things I also wanted to touch on when we was talking about the security aspect of, or you know, worrying about somebody entering your system, you should also have hash. You know, a hash value that if something changed, or a CRC, that if something changed, then that CRC changes.
Right.
Regardless. So
you know if your versions are off and things like that is where you're able to check exactly.
Anything with safety should, and you should have two modes in the robot. There should be a working mode, so there should be a base program, and there should be a security program. And the security program should have preference over everything, because safety, the Cobot should have the human safety and the equipment safety as a rule.
Right.
You know, so I would say those are important also.
Yeah.
Which makes me lead to this question: is a version of Git control something that should be investigated, like in the future, as far as if you're doing robot config changes, and you should have the ability to call for a Git, like every robot have its own Git repository, so you can actually go back and actually see the version history and version control.
As long as you mitigate if the GitHub or your Git control is compromised, that those systems you have in place. The only thing with anything that connects to it that's outside of say its own is in its own internal. So the internal network should have some type of firewall or some type of application in between that monitors. You should have some kind of SIM or something that's monitoring. Okay, it's okay to send traffic out, but but this traffic cannot come in from port A. So you should do port You know,
port
pay
blocking.
only the ports that are necessary.
Yeah.
Only
And-
the services that are necessary.
And you know what I mean, like git control and you know source control.
But I think it's a good idea.
Subversion and stuff like that. Is you can run a lot of that locally. You know, don't run it on the controller itself. You know, by golly. But
on an interface with something.
right, like if anything, you know, and this is what I thought about it was each and every robot has its own Docker container that holds that subversion data that says, hey, guess what? This is your last Git config. And somebody can log into the Git for that robot and say, cool, here's my last config. If something's off, it's going to show red. Say, hey, guess what? I got a problem here. You know, and then at the end of the day, all gets configured to the main central repository that holds everything just in case of an offsite cold storage, your robot data. You know, just in case something does happen, you have to cold store that stuff. You can always recall it back later.
Digital twin is a good idea, but in general, when we're talking about we verifying that something is something changed, when we see a CRC change or a hash change, generally you want that internal, and then you're just pulling that data from somewhere else. But yeah, I agree. You should have some type of documentation in place. Some like some of the PLCs use version dog. You might even implement an ignition application that has a dashboard that's updating this thing in real time in conjunction with you know Git application. I think it makes sense.
Yeah.
Everything that happens, you should have some kind of.
Because we're trying to get interconnected, anyways, right?
Well, we're talking IoT too, so you want to leverage that too.
And to be able to publish and read, you know, or request data, stuff like that constantly.
Yeah.
So,
And the thing is that type of stuff. I think and this is where it goes back into robot safety and security. Is I want to be able to cold store all of my robot config for every single robot I own. And the reason is if I have a massive security breach and something goes completely, belly up,
roll back.
I just got to pull down from my cold store, fire it back up, and off we go. Instead of, oh, woe is me, now I have to go back and reprogram all this nonsense. I want to be able to cold store all of this, keep it in a central repository where I can go get it later. And also, if it's under, Git control or subversion control of some sort, I can see if anybody's kind of dinked with it while it's been sitting there, because I'll see the last update date. If it's not from my own internal system, because everything in a subversion is hashed to the repository that it came from. So, because if you ever look at how like Git config works and all the other stuff, it's hashed to your PC, so it knows you're the one making the call. You have to have that control. So every single robot has its own login. And it's pushing. And if I see, hey, Joe Schmuckatelli made a change, oh, well, that Joe Schmuckatelli doesn't equal robot 001. Now I got a problem.
Got a problem.
I mean, you would take a snapshot because you need the snapshot of what happened at that time to have a record, because maybe it's some legal things that you have to have. So you have to be able to say, hey, I have an image.
Yep.
Here's the image of the condition we were in first. Then you say, hey,
Blow
it out. Well, two things. You verify that what you're going to roll back is what state you're in, because maybe it was some program changes that got missed.
Yeah.
Maybe. Because sometimes we do incremental backups. Sometimes we do full backups. And it depends on what the schedule is. Maybe this robot wasn't in that window.
Yeah, which makes sense.
So it also makes sense to validate what's here before you put it back, so you know what has to be added.
Right.
Based off of the last snapshot you had.
And the thing is like if you start thinking about like Git and version control stuff like that, it's on config. So it's on every time. So every time you'd say okay, you'd commit. So every time you're saying, hey, guess what? I'm making a change. Every time you say okay, it's saving that. It's knowing that data is there. And then as soon as you hit, you confirm config change or confirm robot position change, as you're confirming it before, and when you save that running config and it sends it off to Git, it now has that data immediately.
Yeah. Which
is, for me, I've never seen anything like that.
Yeah.
As far as an automated backup, especially coming from the TouchPennant, because that's or from the config interface. If you're using something that's not like a cloud-based environment for some of these,
so sometimes the problems you run into with some of these systems you can only access certain parts of the database in the robot. So some things are kept on the controller.
Right.
So for example, firmware.
Yeah.
It may tell you what level firmware you were at, but it does not mean that it actually puts you back to a firmware that has some type of tech package that was an update.
Makes sense.
That's from a different repository, but I'm assuming that repository is tied to that Git also.
Yeah, I would.
Yeah.
I tie it all to it, and because I would make sure that every single one of my robots and any subsidiary equipment around it's reporting. Because then all I have to do is, in case of a cybersecurity breach, I just got to yank down the entire cell config and say, run, and then everything's back up again. And then it minimizes my downtime.
So localize your networking system. Yeah.
There's one other step you have to do with that.
Yeah.
So regardless of when you blow out a system, you
Yeah.
will have to do a TCP check.
Yeah. Well, yeah, of course. But
Yeah. So I mean, like you would have to have your SOP in place for when you recover. So your recovery process need to also for the user on the floor.
Right.
The user on the floor needs to understand that process also, and then some validation has to be done between the admin side and the user to verify to do. Hey, okay, we're good.
And the thing is with that, I would put a team in place. That's their entire one of their entire jobs is making sure that Git repository is working. Make sure that IoT data is actually is responding and reporting and being configured, because it's just an extra safety level of safety mechanism. That even pops in, because at that point, if a safety barrier is broken, we know it was broken. It's been reported saying, hey, guess what? You broke the safety barrier. Or, why did the light curtain clear itself when somebody was inside the cell?
And that depends on this is what I mean.
Yeah.
You have a standard program and you have a safety program.
Right.
However, the standard and the safety can be modified.
Right.
If somebody programs the light curtain wrong and puts the safety aspect of the light curtain in the standard, then it can be manipulated without a CRC change. Because the standard library, the standard PLC, because it's a redundant PLC, it's able to be written to and overwritten.
Right.
So you can read, write, overwrite. In the other one, it's a CRC change in the safety. So if someone in the implementation, and this is not so much in Cobots because I'm assuming they have modules and you're not able to do what I'm saying, but I'm saying sometimes the human can change parameters which could change the behavior of how the technology works. You have to account for the human.
Right.
You have to account for somebody saying, well, you know what? I can hold the reset button, and then another person hold the reset button, and I can jump in real quick, and then he hit the reset button again. Why they would do that makes no sense, but humans do crazy things.
Yeah,
Right.
get hurt. Yeah.
So I think the next thing that needs to happen is the same thing we do with the CAN bus systems in the car.
Yeah.
Where each of those systems has a brain and all those brains can communicate, and then it's a conductor that says, hey, I'm monitoring what you're doing. Hey, you're wrong.
Yeah,
You
don't do
got
that.
a problem, low fuel, or hey, you
Yeah.
need to change the oil, or hey, temperature too high.
Yeah.
I think you need the same thing with all of the peripheral devices that connect to the Cobot.
Yeah.
Cobot is master, but the Cobot should know that, hey, somebody's trying to tamper with the safety aspect. And it should say, well, you know
Or
what,
like
you're
an
tampering
error.
with safety, shut down.
Yeah.
And the thing is
Yeah.
I think that we're seeing a big shift. We're seeing a shift from the industrialized robots to that cobot side of the house. But it's the good thing is people who are working with both don't forget where that technology came from. So it's you always see everything called back home. And say, guess what? This is what we used to do. This is how it needs to be done, and they kind of learn from that process. So I really think that we'll see that also a lot is things that are learning, and I think as we grow as an industry when it comes down to cobots, industrial robots, and stuff like that, we'll see a lot of that stuff kind of be implemented down the road. But
Yeah.
you never know.
I think that maybe some of these companies that are trying to have inspire innovation or trying to get more people to use the Cobot platform, I think they should look at what the cable companies did when they said, "Hey, we'll give you the device that connects you." They should provide some type of basic device that we can give to STEM programs or give to innovators or people that are doing traditional robots installed, that they can get these things at a low price point. And maybe it's, hey, this is a basic configuration. You can learn how the systems work. You can learn how to integrate these, and you can get in at a certain price. Because I think if they do that, it'll be the same thing like Ignition. It'll be the same like AWS, Azure. Hey, you can get a base.
Yep.
You can get a 30-day, 60-day, or hey, you can pay for what you use.
Right.
So I think maybe that's the right way to go to get cobots more industry standard, I think.
I can agree with that.
Yeah, I think we're rapidly going towards a lot of cobots in a lot of different places, and the innovation's kind of taken a big turn, especially when we're miniaturizing some of these robots, and especially I think logistics fields and production are going to be affected by cobots. I mean, we already have something similar in the medical field. Yeah, we're already seeing like a bunch of uses for it. So it's just gonna move us in the right direction. But we just got to consider. I mean, the same thing with AGVs. They just have to consider. They have sensors and things like that. We have things that read back the system so that we make sure that if we see a collision happening, we can stop it, or we can fix it, or a pathing is wrong, or programs, has an issue. So yeah, I think in a lot of places the factory's heads are in the right position. I think price is probably what's the limiting factor.
I would just say if you want people to use Wi-Fi, hey, give them the modem that they can connect to that didn't charge them for what they use.
That's true.
Yeah, it's kind of
pay for as a platform or as a service.
What would it be? Cobot dial-up?
Yeah.
or you have AWS, you have Azure. Why can't you spin up a virtual representation of this so the person can at least simulate this in a simulation program?
Yeah.
If not, if we do go robot dial-up, can you please make the sounds that AOL did?
No, please. I don't want it anymore. I still hear that sometimes. Yeah, no.
I mean, we need to consider 5G when we're talking about using some of these things.
That's the thing I was gonna say too. Is it's like we get a little bit off topic, but when you think about networking, you think about Wi-Fi, you need to think about interference. You need to not be like most places and just throw everything on the same channel and say, well, I wonder why it's not working. It's because it's all interfering with it. They're talking back to each other. So there's a lot of like kind of low-hanging fruit, like should be simple fixes that we would think, but some places where they get too big too quick.
Yep.
They're thinking about sizing up and simplicity scales.
Right.
So like you need to make the system robust like we're talking about, but if you can make it on a smaller scale, then it'll only just get that easier to scale
Don't put your 2.4 megahertz robot next to a break area, because it won't work as soon as somebody goes to make a breakfast.
Yeah,
it will
we get
work.
Downtime every time someone goes to.
It will work if you
food.
define that particular wireless access point is dedicated.
Yeah.
Because you're
fair.
dealing with 3 networks in any environment that's industrial.
Yeah.
Right.
Or any manufacturing environment. You're dealing with 3 networks.
Yeah.
You're dealing with the sensor network and everything that connects to the robot.
PLC
That's one
network,
network.
Yeah.
Whether it's CAN bus, Profinet, Modbus, whatever the protocol is for that robot. You're dealing with an internal network for the shop floor. And then you're dealing with the next network, which is the one that if I'm gathering data, it's my business network that is probably firewalled and has a gateway to get out to the internet.
Yeah. But I will tell you this from experience, that there is an AGV running Raspberry Pi. When it goes by a microwave and the microwave's turned on, it doesn't work anymore. So it stops until you change it over to 5G.
But then again, see, that's that problem if someone didn't configure that right. Because what it should say is if I'm not connected to such and such, and the shielding should be such that I cannot, all these things you're talking about can be put in place if we're talking cobots,
Yeah.
and adding AGVs as an aspect of the cobot, then when you set this up, should determine, hey, only these things, and if it's a microwave issue or an interference issue, you should say, well, okay, those things cannot be in this area. In this bubble, nothing that has this frequency can be in this area.
Yeah.
It's common practice. The military does it all the time.
Yeah.
And, that's been addressed, thank goodness. But, we always thought it was funny because, you're getting downtime for your process because, well, somebody decided they want to make a burrito for lunch. So
And it happens.
it does.
Sometimes you don't know that something's going to
Exactly.
interfere.
You don't really understand that, if somebody went and bought a 7-Eleven burrito that first thing that morning, that's what they want to go for.
Okay.
They're
going to ruin their day twice.
Oh, yeah, believe it.
Well,
there are some people that do like those 7-Eleven jumbo burritos and wonder why at about 12 o'clock they have some problems. But that's not us to judge everybody else's eating habits.
I like a big gulp though, so it makes sense. You want the food with the drink. So.
Ooh, that's a one way. Oh boy, you might want to buy some wipes while you're there.
At the gas station?
Well, gas station sushi's never bad for you.
Yeah, right.
I do think that maybe in the future we should touch on best practices, maybe architectural things that you should consider. Hey, what are the doing gathering requirement gathering? I'm sorry, excuse me. Those type of things. What do you want?
Yeah.
How do you make a scope of work for whatever application?
Yeah.
And not just the thing you want it to do.
Yep.
Hey, how do I extract data?
And that should be where you start. But then
Yeah.
you always got to dig deeper.
Yeah.
And I think because we are coming up on the end here, I do think maybe next week we might want to talk about that. Is a robot implementation plan. How do you develop a robot implementation plan?
Like say you have
from concept to the fact that you have to have your maintenance plan in place before even going through commissioning.
Yeah.
Noble concept for some people, but and we understand.
You mean I have to plan ahead?
Some companies we are very familiar with do not do that.
Put it on the floor. Whatever it hits, I'll pay for.
Exactly.
Let it go.
But we might cover that next week, and we'll kind of really talk about robot implementation plans and going all the way down into the maintenance cycle and maintenance plan. But the thing is I want to take a moment to say thank you. I just looked at the numbers again. 2,513 of you is tuned in to listen all across the world, and I just want to say it has been a fun time, a dream, to have this and stuff like that, talk about it. We want to say thank you to every single one of y'all. Go take a look at we redid the website. We're probably gonna be coming out with a new logo here soon. Go take a look at the blog, and stuff like that. We're gonna be adding some more stuff about cobots on there. We do have a couple other things coming. We will be, if you are interested in it, myself and Tim will be at SEMA in November out in Vegas. So you'll see us walking around out there talking to some people, especially talking about how we can get cobots in the automotive industry as far as in that side. How can we support the automotive aftermarket using cobots and stuff like that. So we'll be talking about that. So, but I just want to say thank you, and I'm going to turn you over to the rest of you guys. Y'all have a good one.
Well, guys, like I said, it's been a little while since I've had a chance to talk with the guys and talk with you guys. Really enjoyed talking about tech. Life happens, and sometimes you just have to take care of those type of things. But I should be back now more regular. I've gotten those things under control. But the thing I would like to challenge everybody that's listening. So we're almost close to 3,000 listeners. The channel is not ours. It's everybody in the community. We've talked about it before, but we would like to know, is it any interest in you guys having a Discord or something where we can maybe have some additional things that we do with you guys? You can help support us and help the channel grow, and maybe even help us come up with some new content and some other things. I'd just be curious if you guys be interested in that, and we can come up with some. If it's enough interest, maybe we can see if it makes sense to make some kind of level maybe a level of everybody that's a free level, and then some intermediate level, and then hey, this is the super level,
like a Patreon.
But, I'm just curious if maybe you guys would be interested in that. Like I said, the channel is for everybody that's listening, and all we do is enjoy giving you guys content.
Yeah, so I'm very appreciative. I think that makes sense. Having a place where input. I mean, your input's valuable, so we definitely are always listening, and we understand that if you don't like something, you're just not going to watch it, right? I mean, it just makes sense. But so we're trying to help tailor kind of what we can create, what we can bring to the table to what your needs are, what your wants are, what you're curious about, things like that. So it's definitely beneficial for you to reach out to us. I mean, check out the website. You've got printedheritage.com and things like that. So there's plenty of places there to kind of reach out to us and kind of start the conversation. We're never going to turn our backs to knowledge or anything like that. So we're always curious, and we welcome the fact that you guys are listening and that you guys are interested as well. So once again, thank you. Stay tuned, guys, for more, and let us know what you think.
There you go. Have a good one.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.